right, good morning. We are in topic 8, block 1. We're dealing with equations and inequalities. Today's goals and objectives are going to be for us to analyze situations involving linear relationships and formulate linear equations to solve problems. And we're going to determine if a value is a solution to an inequality and interpret the solution for given context. So before we get started today, I just want to kind of review the types of equations that we created in the previous topic, in topic 7. And so basically what that's going to do is that's going to build a foundation for us, okay? So think of the equations that we created in the last topic. Does anybody got an idea of one that we did? Nobody has one. What about like when we did proportions? And so we had like 1/2 equals x over 10. And we had to multiply the denominator by 5 to get 10. So we had to take 1 and multiply by 5 to get x. Do y'all remember setting those up? If you do, give me a thumbs up. If you don't, give me a thumbs down so I know. All right. So who can give me an example of an equation?
I think it's when you grab a decimal fraction and you times it by x.
Okay, that would work. Could we say x equals 3 plus 4?
Yes, sir.
Yeah. What would x be? Yeah, it'd be 7. Good. Does anybody know what an inequality is? When you were little, you probably thought of it as the Pac-Man eating the bigger numbers. So what does that make you think of? Instead of using the equal sign, what sign would you use? Yeah, the greater than or less than sign. So instead of using an equal sign in inequalities, whenever we create equations, there actually would be called an inequality because we're not using an equal sign. We're using the greater than, less than, or greater than or equal to, or less than or equal to sign. So does everybody understand the difference between an equation and an inequality? What's the difference? What do equations use? Talk loud. What does the equation use? Does it use an equal sign or a greater than sign? Yeah. Equations use equal signs, and inequalities use what type of signs? Yeah, greater than, less than, greater than or equal to, less than or equal to. All right. So what we're going to do is we're going to first look at this game and look at the different types of aliens we got here. So I want you to think about how the patterns might be involved in the growth of the aliens on this page, okay? So let's take a look at this. If you would you read this for us, Tashandri?
A special individual game features growing alien families. Large aliens have more body parts and more special powers, so they are more difficult to defeat. Mathematics skills and strategy will help you win the game.
So just looking at this, how do you think they're growing?
Some blocks are added every time you move to the right.
Okay. They're weird looking. I know that. I'm trying to look at them at the same time y'all are. Trying to see if y'all noticed anything else. Nobody sees anything else? Well, let's take a look at page 2. See if we notice anything. All right, so look at this. Read this for us, if you would, Azamian.
How do you want to create the fourth cobra?
All right, so look at that above it, though. What's it say about the first aliens?
Oh, the first aliens in the game before the Cobra Co family. What the? I don't know how to say that.
What
Cobra
pattern?
Co. What pattern do you observe? Use animations to explore how the Cobra crabs grow.
All right, so it says the first 3 members of the Crab Co family are shown. What do you think the 4th member of the Crab Co family will look like? So I want y'all to take a look at those tiles and see how they're growing. So does anybody notice anything special?
They get wider.
They are getting wider. Well, are they getting wider or are they getting taller?
Taller.
Yeah, they're getting taller. How are they getting taller? Like what's happening every time?
We're adding to them.
How many are they adding to it as it gets taller?
3.
3 in the middle or the bottom or the top?
The middle.
All right. So let's try to create this. So we got this little dude. So how many spaces are going to be beside his head?
2 on each side.
All right. Then we need his crab arms. It's pretty gross. What do we need to do above him?
Add 3 rows.
Like this? Looking for a yes or a no. Is it looking good?
Yes.
What do I need to do now?
Add his little hat on top.
All right. So let's see if we did it right. Did we do it the same as them? Doesn't it look the same?
Yes.
Yeah, it's the same. All right, let's take a look at what they got on the second one. Ooh, how many people were thinking like this? Were you thinking with math or were you just thinking? I was not thinking with math. I'm going to be honest.
My brain stopped when I just saw this.
Oh, all right. So it says since larger aliens are more difficult to defeat, study the growth patterns for the family of aliens. The patterns are recorded in a table. A process column helps you understand the pattern. So, if you would you go over those for us, please, Miss Najela? Starting with the first one.
Like read them.
Yeah.
The first one, 3 times 1 plus 3 equals 6. And the second one, 3 times 2 plus 3 equals 9. The third one, 3 times 3 plus 3 equals 12.
Cool. So, how would we find out the bottom one? Like, no matter how many, whatever number the family member is, what would we have to do here?
You do 3 times whatever the number is plus 3.
I agree. Do y'all agree?
Yes.
All right. So looking at the rule that they came up with, it says y equals 3x plus 3. Isn't that what Najela just said?
Yes.
Yes. Thank you. I love when y'all participate. All right, so if you would, let us know what that says right there, Samantha. Or anyone else that can help her.
I will.
Go ahead.
An algebraic rule represents the relationship between a family member and the numbers of body parts.
Perfect.
Mr. Marr,
Yes, sir.
I just completed that assignment thing. I'm finna do my 2 quizzes now.
Sounds good, buddy. Keep working. Keep up the good
Okay.
work. All right, so it says here's an equation that can help determine which family member described by the rule has 18 body parts. So, what could we do so that we can figure out what x is? Does anybody remember how we solved for x?
I don't know how to solve for x, but I know here we can do 18 divided by 3.
All right, so we are going to end up dividing by 3 after a little while. But the first thing that we have to do is we have to try to get 3x by itself. So we have to undo what's being performed beside it. So we have 3x plus 3. So we have to undo this. So to undo something, we do the opposite of it. So what's the opposite of plus 3?
Minus 3.
So if we do this, this is going to combine to make 0. And if we do something to one side of an equation, we have to do it to the other because it's like a scale. So when we do 18 minus 3, what do we get?
15.
Correct. So now our equation is 15 equals 3 times x. So how do I undo 3 times x? Or how do I get that x by itself? Yeah, we're going to divide by 3, and 3 divided by 3 is 1. What's 1 times x?
1.
Kind of. Anything times 1 is what?
The same.
Yeah, it's itself. So it would just be x. And if we do something to one side of the equation, we have to do it to the other. So 15 divided by 3 equals
5.
5. So 5 would equal x. So let's see how they show it to us. That's how we do it algebraically. So let's take a look. So they say that the first one is 1 to 6, the second one's 2 to 9, the third one's 3 to 12, the fourth one's 4 to 15, and the fifth one is 5 to 18. And that's based off of y equals 3x plus 3. So thinking about that, y equals 3x plus 3. If you'll notice, here is our y, and this is our x. If we go to 3, that's 1, 2, 3, right here. And then we add 3 each time, what happens? Watch, if I go over here and I go up 3, that'd be 1, 2, 3. All right, that's 1 to 6. So if we did it again, what would happen? Now I'm at 2. So then I would go from 2 to what?
9.
Yep. So if I'm at 2, let's see. 3 times 2 would be 6 plus 3.
9.
Yep. I would be at 9, which would be right here. And if I was to do this again, isn't that the same amount as the first one?
Is it?
Yes, it is. And it would just continuously do that all the way up to here. All right, y'all are going to learn about that soon in the 8th grade. So I won't get into it too much now. But it says, how did the table and the graph show the solution to the equation 18 equals 3x plus 3? Well, we know that x is what?
15.
Is it 15? 5. All right, so let's look at this scale. Read this for us, please, Zayden.
Let me zoom in. The first aliens in the game belong to belongs to the Carpco family. What pattern do you observe? Use the animation to explore how the Carpcos grow.
All right, so looking at this, it says, like tables and graphs, balance scale models can be used to solve equations. So here's a balance scale model of the equation 18 equals 3x plus 3. So if you notice, this is 18 on the left side, right here. This is our x, and this is our 3. Because this is 1, 2, 3 x's because they're unknown values. But you notice how the scale is evenly distributed. Does everybody understand that? How it's sitting at the same level, height?
Yes, sir.
Okay. So let's take a look at this. It says algebra tile models can also be used to solve equations. And here is an algebra tile model of the equation 18 equals 3x plus 3. So what could you do with these? How would you find out what these x's are?
Divide.
Well, in other words, you know this is 18. You know this is 3. So division would work. But wouldn't all we have to do is figure out what we need to add to 3 to get 18?
Yes, sir.
And then what would you have to divide it by? How many x's are there?
3.
Yeah, there's 3 of them. So what plus 3 is 18?
15.
And 15 divided by 5 is what? 15 divided by 3 is what? 5. Good. I'm telling you the answers early. It's all right. It happens. All right. So based off of pages 1 and 2 that we've already done, we should have been able to answer questions 1, 2, and 3 in our workbook. If you don't have questions 1, 2, and 3 answered in your workbook, go ahead and do that now while I'm clicking on page 3. And we'll be able to answer question 4 based off of this page. Jamal, will you read this for us, please, sir?
Yes, sir. Oh, what's the whole thing?
Mm-hmm.
All right. You may remember creating algebraic rules to represent relationships earlier in this course. You described the ratio of blue paint to yellow paint in 2 different green mixtures as y equals 2b and y equals 3b. You can also describe the cost of pizzas sold at $7, which is the algebraic rule C equals 7. And when a delivery charge was added, you develop the rule C equals 5 plus 7n. Can you think of another other algebraic rules you have used for each rule? Describe the relationship to represents and define the variables.
All right. So I remember doing the cost of the pizzas and doing C equals 5 plus 7n because the delivery charge was $5 and each pizza cost how much?
$7.
$7. I remember doing that, but I didn't remember it until I saw it. Do y'all remember any
I
other?
remember the paint. I I remember the paint.
You remember the paint one? Does anybody remember any other one that we used? We've done a lot.
Does the gas one count?
Yeah, the gas one worked. What was it? I can't remember.
On the way on the trip, and then they need some gas.
Yeah, I can't remember how we did it, but it was miles per hour.
Yeah.
And so it was, we had the miles equaled the gallons of gas.
This might be on which I can't even remember.
I know, I can't either. I remember it was miles equals gallons of gas times how many the actual fuel economy, what it could drive. So it was like we found out that they could go how far on 1 gallon of gas. Does anybody remember? Wasn't it 36? Let's say it was 36.
Yeah, it was
I
36.
thought it was 37.
All right, let's say it's 37. How would this make sense? If M equals the miles and G equals the gallons, how would you make sense of this equation?
Hmm.
37 miles equals 1 gallon.
So you can go 37 miles on 1 gallon of gas. So could you say for every gallon of gas, you can go how far?
32 miles.
All right. So, and anytime you add more gas, what's going to happen?
It adds up.
Yeah, it would go 37 more miles, right? So if you had 2 gallons, it would be 37 times what?
2.
2, yeah. And if it was 3, what would you have to do?
37
Times 3.
All right. Does that make sense to everybody?
Yes, sir.
Good. Y'all remember how to do this, right? There we go. All right. So once you've come up with yours, when I say yours, I'm talking about your other algebraic rule, like the one we just went on over, or you can use the one we just used. Make sure you answer number 4 in your workbook. All right. And on page 4, what we're going to do is preview what we're going to learn in topic 8. So if you would you please read this for us, Layla?
In this topic, you will write rules to describe patterns, write equations from rules to describe specific instances of patterns, solve equations using tablets and graphs, solve equations using balance scale models and symbols to record the steps, and solve equation using algebra tile models and use symbols to record the steps. Each of these important strategies will help you solve problems. You will not only use them in this topic, but in your later work in math and science. For example, equations are used in chemistry and physics, as well as in construction and economics.
All right. Thank you, ma'am. So which of these strategies have we used before? Have we wrote rules to describe patterns?
Yes.
Yeah. Have we wrote equations from rules to describe the patterns?
Yes.
Yes, sir.
Have we solved equations using tables and graphs?
Yes.
Have we solved equations using balance scale models?
Yes.
Kind of, sort of, yeah. We've definitely discussed using balance scale models. And we have used symbols to record the steps because we have done that. Have we solved equations using algebra tile models? I remember using algebra tiles. So, do you think we're somewhat familiar with these?
Yes, sir.
All right. So we're going to continue to use these, and we're the purpose of us is using this is because we're not only going to use this for math. What else are we going to be using it for?
Florida.
Science.
Science. We'll be using it in chemistry and physics, and if you ever do construction and economics as well. All right. Has anybody ever built anything? Nobody's built anything yet? Like a dog house or a little shop or anything like that? Go ahead, Sarah. I've built I built on a room whenever I was, I guess, around 11 with my dad. And then whenever I was 17, I built a house. It was a 2-story house with my dad for my uncle. And I've also remodeled my house before, but I did that whenever I was in my 30s. So it doesn't really matter how old you are, you can still do that stuff. So at any moment, you might be able to use this and you can make really good money doing that kind of stuff. So it's kind of neat. So let's take a look at part 5. Would you read this for us, please, Chandler?
You will also extend the work of what you're doing with equations to solve inequalities. Inequalities are often described as situations that have a minimum or maximum restriction. For example, you might want to know the minimum amount of money you need to save for an upcoming field trip. Statement of inequality are used to make comparisons or to represent sets of numbers. You can use a number line to give a visual representation of the solution set.
All right, so looking at this, it says, can you name some values that make the inequality x is greater than 7 true? So what could x be if it has to be greater than 7 to be true? What's another one?
9.
Could we use any like fractions?
8 halves.
Yeah. 8.5. Anything else? What about like 1,000? Is that greater than 7? Emma whispered yes 2 times. All right. Um, is that complicated, or does that seem pretty simple?
Simple.
What if this sign looked like this? It said x is greater than or equal to 7. What could it also be?
7.
Yeah, it could be 7 as well. Notice how the circle ended up getting what?
Bigger.
Well, it got bigger, but it's closed in, right? It's not open anymore. All right. So that's going to come in handy here soon. All right. So what we're going to do is I want us to answer question 5 in our workbook. We're going to focus on using number lines because that's how we're going to be able to answer these types of inequalities. So I'm going to ask you a couple of higher order thinking questions. What is the relationship between feet and inches? What is the relationship between feet and inches? What is the relationship between feet and inches? In other words, how many inches are in 1 foot?
12.
Yeah. So the relationship between feet and inches would be there are
12.
in. There we go. Perfect. So how many ways could we represent that relationship? That's one. We said there's 12 inches in 1 foot. What's another way we could say it?
1 foot is 12 inches.
Perfect. All right. So we can do it 2 ways. All right. Could we say,
Mr. Mark.
could we say 1/12 of a foot is equal to 1 inch?
Mr. Mark.
Hold up, Zayden. We're talking. Could we say that?
Yes.
Yeah, we could. What's your question, Zayden?
Whenever like I answer my questions on that test, like it keep on popping up them, like it keep like somebody keep on saying something. I think it's like a robot person that keep on saying like the words and stuff whenever I click on them.
Oh, that's because you're clicking on the ones that have the little dots under them. If you click on it,
Yeah.
they'll talk to you. So on like question number 4 and number 7, they're there because for some people the negatives weren't showing up really well, so you can click on them and it'll tell you if it's negative or not. So that's what she's reading to you. So which equation could be used to find the length in feet of a painting that's 100 inches tall? What could you do to figure out the length in feet of a painting that's 100 inches tall? How would you have to convert that to feet? You know it's 100 inches tall. How would you be able to determine how many feet it is?
Divided by 12.
Yeah, you just divide it by 12. So that would be like 1/12 equals 1 inch, I guess. Or you could say 1 foot is 12 inches. So you just divide by 12, just like Emma said. That would work perfect. All right. So in our workbook, there's question 6, A through F. I want you to go ahead and do that. And while you're doing question 6, A through F, I'm going to pull that up real quick so that everyone knows what that is. That's right here. So we're going to be answering this table. We're going to graph it. We're going to make a rule. And then we'll answer these questions. I want us to do that. All right, so this assignment that I open today will be open. You'll go to it. It will say January 19th through January 20th. And that's the work for this week. And that is more practice questions 1 through 5. Now, right now, what I want us to do is I want us to spend about 5 minutes answering question 6, A through F. Let's take a look at it. All right, so on part A, where it says complete the table, it says 1 ounce is equal to 1/16 of a pound. So 1 pound would be how many ounces?
$60.
Good, it would be 16. That's correct. So what would the process be here?
16. No.
I think that works. 1 times 16 would be 16, right?
Yes.
Okay. So how would we find the next one?
2 times 16.
2 times 16.
So what would that be?
32.
Good. How would we do the next one?
3 times 16.
Good. So what would n equal? What's 16 plus 32?
48.
Good. Y'all starting to see a pattern?
Yes.
So each time, if you have the number of pounds, what do you have to do?
Multiply.
Yeah, you just multiply by 16. So what's 16 plus 48?
61.
Say it loud. 64.
Yes.
All right. So how would we figure out this one since we know the number of ounces, but we don't know the number of pounds?
144 divided by 16.
Good. I'm going to do it like this. We would say would equal P.
Yes.
So what's 144 divided by 16?
9.
All right. Now what would we do?
12 times 16.
Oops, I wrote it wrong. What's 12 times 16?
192.
All right, we're starting to get pretty good. All right, so if this is P and this is N, what would our algebraic rule be?
P times 16 equals N.
Everybody agree with that? All right, I got a thumbs up. Woohoo! All right, so if we were taking our graph, I wonder if I can take this. No, it don't move it. Darn. Anyways, if we took our graph and we took everything that we had, so we had 1 to 16, 2 to 32, and let's see, 3 to 48. I'm just going to do those just due to time. P would be our X or our Y.
X.
That's right. So P is going to be our pounds, and N was our ounces. So did y'all just label these 1, 2, 3, 4? And then how did you label these? Like by fives or by 16s? That's pretty smart. All right, so the first one would be 1 to what?
16.
Good. What was the next one?
2 to 32.
Perfect. What was the next one?
3 to 48.
What do you notice about this? What type of line does it form?
A straight line.
Yep, a straight line, and that line's passing through the what?
Origin.
The origin. So what type of relationship does this show? Proportional or non-proportional?
Proportional.
Good.
Proportional.
All right, so it says write an algebraic rule that represents the relationship between pounds and ounces. We already did that. We said that P times something equals N. What did we say?
16.
All right. And if we were answering for, if we were trying to find what P is equal to, what would we do?
N divided by 16.
Perfect. So it says salt is sold in cartons that weighs 3.5 pounds. What is the weight of salt in ounces? What would you have to do?
3.5 times 16.
Perfect. And then you would get your answer. And then let's see. Let's do one of these. Y'all want to do E or F?
E.
E. What would we do to solve for this one? Notice y'all still have to get your answer. I'm not doing that one. Whew. All right. What would we do for this one?
4 divided by 16.
Equals what?
0.25.
There we go. That works out perfect. He said 0.25 pounds. Perfect. How were you able to do that, Tashandra? What can you divide both of these by?
2.
Yeah, you can divide them both by 2, or you can divide them both by 4, right? And when you do that, we get 1/4, which is equal to what Tashandra said. And 1/4 is equal to our answer, 0.25 pounds. All right, and this last one, how would we answer it? What would we have to do?
72 divided by 16.
Do y'all agree with what Emma said? Looking for a thumbs up or a thumbs down? All right, Tashandra gave me a thumbs up. Good deal. All right, my boys and girls, y'all did a fabulous job today. Remember that we have our more practice questions in My Agile Mind to do today. That's questions 1 through 5. If you have any makeup work, it's all open today until 6 o'clock. So make sure you get it completed as well. Does anybody have any questions before we're dismissed?
Mr. Mark, can I talk to you after class when everybody leaves?
Yes, ma'am. All right, my boys and girls, I wish you a very great day, even though it's rainy, and I will see y'all tomorrow.